Hi, hello. This is Ayala Reyes, and I'm going to do a tutoring video for TBP. I'm a third-year junior at Wayne State, and my major is mechanical engineering. And today we're going to go over ECE3300, which is the intro to electrical circuits, and it's one of the first courses you kind of have to take as an ME major. We're going over chapter 5 today, and the beginning of chapter 5, we're going over, if you can't already tell, we're going over source transformations. Boop. Oh goodness, I'm so bad with writing. I'm doing this on my laptop. We're going over source transformations, and I'm taking Professor Lubna Alazzawi for this course, so if that matters, this is going to be the homework you're going to be seeing and what she's going to go over in class soon, or she did go over class. So before we kind of dive into the homework problems though, I kind of want to go over the basics of source transformations again and how to add up sources. So there's only kind of two sets of elements we can source transform, and that is a voltage source in series with a resistor, and that transforms into a current source in parallel with a resistor. And so this double-headed arrow kind of says they're interchangeable. So this can transform into this can transform into this. And whenever you see those combinations in a circuit, you can turn them into one another to make the circuit easier to solve, basically. And these are the equations. So if you want to turn a voltage source in series with a resistor into a current source in parallel with a resistor, you want to find your new current source. And this is basically based off of Ohm's law. And you take the voltage source divided by the sum of all of the resistors in the series, or just one. And then vice versa, if you want to take this and make it into a voltage source in series with a resistor, your new voltage source is based on your current source times the sum of all your resistors in parallel. And just a quick brief on how to add voltage sources and current sources once again. You just want to make sure for voltage sources that like the signs line up. So like as you can see here, the pluses line up. And so when that happens, you can just algebraically add your voltage sources together into one. You can make it into one. If, let's say, a voltage source is in the opposite direction of your other one, so let's say this is like V1, V2, you just kind of flip it. You could just flip it, and you make your voltage source negative. So you just take the negative of whatever this is, and then you could add them together. Oopsie. And then you could add them together. So that's that. And then also with current sources, they kind of just have to be facing the same direction, and then you can add them. So current sources though have to be in parallel for you to add them. Voltage sources have to be in series to add them, by the way. But again, the same kind of rule applies for current sources. They have to be facing the same direction. If one of them is facing the other way, you flip it, and then you just take the negative of that current. So just to kind of, oopsie, demonstrate that. So like, let's say these are very bad drawings, but this is I1, this is I2. Just kind of take that, and then you put them in the same direction. I usually just like going up. You just take the negative of whatever current source you flipped, and then you add them together. Ooh. Okay, sweet. Okay, so now that we know that, I'm going to move this to this side so we have more room here. Okay, so this first problem, we're going to source transform this right side of the circuit, the one in the red, and then we're going to determine the value of I, and then it says to determine IA, but she only gives the answer for B, so I don't think we have to do that. But so it's good first to identify like which parts of the circuit we can transform. So again, voltage source in series with a resistor, or current source in parallel with a resistor. So this stands out. This stands out. And for sure we can source transform both of these parts, but again, it wouldn't really make sense to source transform both of these parts because we want to add voltage sources to voltage sources and current sources to current sources. So these are just going to change into the other one. So, and we still can't add them together. So it's best if we just source transform one of them and then add the sources, the respective sources that way. So for this problem, I kind of just chose this source to source transform. So let's do that. So to find out the new voltage source from this, we're going to take Ohm's law, which is V equals IR, so current source times the resistor in parallel, which is 0.5 amps for the current source times 2 ohms, which is 1 volt. And so we can draw a new circuit of what it looks like, of what this part kind of just looks like. So it's going to look like this. So wherever like it's pointing up, so wherever it's usually pointing, that's usually the positive side. And then the tail end is the negative side. So that's how I know which of these signs to go with. Oops, sorry. This is going to be 2 ohms. So your resistors are always going to be the same. Like whatever your parallel resistors are or whatever the sum is, it's always going to be the same when this source is transformed, but this is different. So this is now 1 volt. And that's in parallel, or I'm sorry, series with these. So that is 2 volts. This is 2 amps. This is 4 amps. Okay. So now, and then it's good to know that the circuit doesn't end there because this resistor is in parallel. So what we want to do now is we want to add the resistors and the voltage sources together. So our circuit would look like this now. Sorry if these drawings are kind of crappy. Oops, just missed it right there. So this is going to be -1 volt. Oops, this is going to be 4 amps, and this is still 4 amps. So just a quick reminder, these voltage sources look like this in series. So I kind of just switch this top one. Oh, I actually switched the bottom one. Excuse me. It doesn't matter, just as long as the pluses are all on the same side, you could still add them together. So when it goes like to this side, onto the right side, when it slides down, the plus will be at the top. Yeah, I guess I kind of did that weird. Let me see if I can try to rotate it, question mark? Nope, I can't do that. But just visualize that this is at the top, like you're looking at this at the top, and this is at the top, and it slides down. So the positive is on the top now, if that makes any sense. And then the resistors just add up like normal, so 2 plus 2 equals 4. So now we're going to source transform these two, the -1 volt and the 4 amps, into a source, a current source, in parallel with a resistor. So to find a current source, or Ohm's law, which is the voltage source divided by your resistors in series. So this is -1 volt divided by 4 ohms, which is -0.25 amps. Okay, and so our new circuit is going to look like this. That's -0.25 amps. And then our resistor stays the same, so it's 4 amps. And this is still 4 amps. And then now we can turn and then source transform this again. So we can add up these resistors now, because we can only add up resistors in parallel with each other, or because we can't, because these resistors before, so this 4 amp, these resistors in this position, were not in, like this was in series with this, but this 4 amp series was in parallel with this, so we can't add them. But now we can, because we source transform this. So that's why it was important to source transform this. But now we're going to source transform it back again. So now we're going to find a new voltage, which is the source, the current source, which is -0.25 amps, times. So how to add up parallel sources is just the inverse of the sum of their individual inverses. So if you can see, that's 1 over 4 to the -1 plus 4 to the -1. And then when you equal all of that out, it's going to become -0.5 volts. And then our new resistor is just, it's the sum of all the resistors that we had for the problem. So the new resistor that's going to be in our new source transform is just this term, which was 2 ohms. So now our new circuit is going to look like, with this left side added now, it's going to look like this. Plus minus 4 amps right here. And then why does it never connect? Just imagine they connect. 2 amps right here. And this is negative 0.5 amps. So, oh, I forgot to put the 9 volts here. Also, that is not amps. Yikes. This is a voltage now. So sorry. But now to find I, which is just the current going like this, we can do KVL, which is Kirchhoff's voltage law. And we can go this way because that matters. So we're going to start with this. So it's going to be a negative plus 2I plus 4I plus 9 equals 0. So this is going to be 6I plus 9.5. 6I equals negative 9.5. I equals negative 1.583 amps. And that is what our answer is. Yay, we did it. Check. Okay, awesome. This is the sum of my work if anybody wants to see that. If anybody wants to know how I got from this to this. So from here, this is how I got that. And then this. Okay. Yeah. Okay. So we can do which one? We can do this one. Let's do this one. So for this one, we just have to determine IA again. Actually, I'm so sorry. I changed my mind. We're going to do this one because we're solving for voltage. And we haven't done that yet because this one is another current one. So we're going to do this one. And as you can see, it is kind of wild, but we'll get through this together. So first things first, Luke, you kind of want to combine things that are already, like that you can combine already. So like the first thing that goes to my mind are these resistors. So you want to combine those first, and then once those become series with this 10 ohm, combine that. So to find the combination of these resistors, you want to take the inverse of their individual inverses, and that's going to be 2.5. I'm so sorry. No. That is 2 ohms once you plug it into your calculator. And so that little part is going to look like this. 2 ohms in series with 10 ohms. That's obviously just 12 ohms because they're in series, so you just regularly add them together. Okay, so now that we did that, there's also, it's in parallel with this current source, which is 3 amps. So this little part right here, this top part, we're going to kind of switch it together before we tackle the rest. So it's one big circuit, one rectangular circuit instead of this mess. So we're just going to source transform this really quick. So Vs equals the source, the current source, which is 3 amps, times the resistor in parallel, which is 12 ohms, and that's 36 volts. Okay, so now we will rebuild the circuit with this new source transformation, so it looks a little more manageable. Just a little bit though. Actually, we're gonna source transform these two because it'll make it even more manageable. So with that one, we'll just do it to this side. You can find a voltage source again is equal to your current source, which is 2 amps, times your resistor in parallel, which is 16 ohms, 32 volts. Okay, let's rebuild the circuit. And now it's going to look like this. Okay, let's put all the signs in. So this was the 36 volts that, I'm so sorry. This one was the 32 volts. This is in parallel with the 16, I'm sorry, in series with the 16 ohms because we just source transformed it. This is the original 20 ohm resistor. This is the original 8 volt source. This one is this source transformation with the new voltage of, 36 volts. This one was the 36 volts. I got confused because they both started with 3. And then with the same value resistor, 12 ohms. This is the original 7 ohm resistor, and this is VO, so the thing we're trying to find. And then I, which they actually gave us, which is 2.5 amps, which will come handy later on. Okay. So now what we want to do is combine the sources and the resistors in this mesh. So that's going to turn out to be this. We also were combining the resistors in this second mesh right here. So this is going to be, this is, since this minus isn't the same side as this minus, we just made this one negative to turn it around so they're on the same side. So 32 minus 8 is 24 volts. 16 plus 20 is 36 ohms. This is still 12 ohms. This didn't get added in because it's in parallel with everything else. This is still 36 volts. These two resistors got added, and this one is now 19 ohms. And this is still our original VO with our original current. So now we want to source transform either this left side or this right side into a current source in parallel with a resistor so that we can integrate this 12 ohms in to make it one huge mesh instead of two. So to source transform this, we're going to find the current source by taking the voltage source divided by our resistor in series, which is 24 volts divided by 36 ohms, which is 2/3 amp, or about 0.6667 amps. So now that's going to look like this. I'm going to move this part up here so I can redraw the circuit to show you guys what that would look like. So now this is a current source in parallel with a resistor. So I'm only going to draw the left side actually. I'm only drawing this left mesh to make it easier so that we can only focus on one thing at a time. So this is 2/3 amp, this is still 36 ohms, and this is still this original 12 ohm resistor. So we can add these resistors together now that they're both in parallel. And it's just going to be the inverse of each of their inverses. This is how I do it. I know that there's a formula where you multiply them and then you add them in the bottom, but I just like using the original formula because that's what I remember. You can use whichever formula you want though, but that's going to become 9 ohms. Okay, so this is what the left side of the circuit looks like now. So, and as you can see, this circuit, this source, this current source still isn't the same as these voltage sources on the right side, so we can't add them together. So we're going to have to source transform this one more time to go back into the original voltage sources so they can all be added together. So we're going to find the voltage source by multiplying the current source times resistor in parallel, which is 2/3 amp times 9 ohms, which is 6 volts. Okay, so now we will build this circuit one remaining time. So this will look like this. Oops. So this is still the original VO. This is still 19 ohms. This is still 36 volts. And now the 12 ohm is gone, and we've source transformed into this final form of a 6-volt battery with a 9 in series with a 9 ohm resistor. Okay, so to find KVL, we just, oh, I'm so sorry, to find VO, we do KVL, which is Kirchhoff's voltage law, and then we go around. Just a side note, you can also like add these resistors together again, and the voltage sources. You can do that, but it's all going to be the same thing because we're going to do this in this Kirchhoff's voltage law anyway. So we're going to start on the 6 volt. So 6, it's going to be a negative. And since we're kind of going this way, like clockwise, it's going with the current. So it's going to be 9I minus 36 plus 19I, oopsie, minus VO equals 0. So this is going to be 19 plus 9 is 28I minus 42 equals VO. So we switch the VO to the other side. They gave us the value, which is 2.5. So 28 times 1.25 minus 42. And VO is 28 volts, which is the answer to our problem. Yay, we got that correct. Okay, so I think this is it for source transformation. I know it's a lot, but this is kind of me zooming out to show you guys all of the work. If you want to screenshot it or something, just go ahead if you want to. As you can see, like my thought process and all of this, I'm a very visual person, so I like rebuilding the circuit a lot, many times like this, just so I can keep it straight on like where the signs are, where the resistors are. It's very hard to kind of keep it all track in your mind when the circuits are just as complicated as this. And keep in mind like what the ending circuit is going to look like. So like if most of the circuits like voltage sources, you want to source transform anything with a current source and vice versa, right? So if most of the current at the end is current sources, or the thing you're trying to find is a current source, you want to source transform anything that isn't a current source already, right? So that's just kind of my tip for this one, is to source transform it into the same type of source, the same type of source. So all voltage sources, all current sources. That's mostly though in the end, because I know in the beginning it's easy to source transform everything you see, but just keep in mind like how many times you have to kind of go back and forth into everything. But that's it for my video. I hope you guys enjoyed it. Sorry for all of the going back and the messy handwriting, but this was a lot of fun. Thank you for listening to me, and I hope you guys pass the course. Okay, awesome. Bye.